All right, welcome back to Math Principles and Applications from the comfort of your own home. So this week what we're going to be looking at is something called compound interest. I'm going to have one or two videos on it. You guys watch those videos, you'll answer a couple of questions. I'll give you an answer key for a couple of those questions so you can check your work. I'll be available to answer any questions that you have through email, and then we'll have a short quiz on this stuff on Friday, and that will be it for the whole week. So, first off, compound interest. What is that? Well, when you put money in a bank account, they pay you interest. I think you guys know at this point. The way that interest works is they give you, say, 2% interest, and then when they give out a loan, they're actually loaning someone else your money, but they're giving them an interest rate of like 3%. So they're charging a higher interest rate than they're paying out, and that's how banks make money. But they're a business, so they're entitled to do it. Anyhow, let's take a look at Excel to show how this actually works. So we've got 12, we only have 11 here. There we go, 12 months. Okay, in those 12 months, you're going to figure out how much interest we're going to get over the course of those months. So let's say you start out with $1,000 in your account, and they're going to pay you 2%. Now the catch is we're not just going to write 2%, we have to have it as a percent, or excuse me, as a decimal. So we do 0.02, and we're going to multiply that times the starting amount in the account, okay? And that's $20. So the interest that you get, 2% of $1,000 is $20. So now your new total at the end of the month, you take that $1,000 that you started with, and you add that interest that you've accrued, okay? Now that interest has just been what's called compounded, meaning added to the new total. So now, at the start of the next month, what you have in the account at the start of the next month is what you had in the account at the end of the last month. So now, when we take our 2% interest, 0.02, and we're multiplying it by now $1,020, not just $1,000. So now, instead of getting $20 interest, we get $20.40 interest. So now we move on to month three, and month three, what we have at the start of the month is what we had at the end of last month. And once again, we're going to take 0.02 times how much money we have in our account. Okay, and we get $20.81 interest. So it was a 40 extra cents last time. This time it's 80 extra cents. Okay, hey, that sounds pretty good to me. Extra money is always good, even if it's just a few pennies. So now we're going to take what we had here at the start of the month plus the interest that we accrued over that month. Okay, and we're up to $1,061.21. Now here's a pretty cool trick we can do in Excel. Instead of doing all those steps again and again and again, I can highlight these three rows, excuse me, these three columns. Okay, now see at the bottom right, there's that little green square. It's called a node. And now watch the cross turns from a little white cross to a smaller black cross. Okay, so I click and I drag that down to the end of those 12 months. Okay, and this is how much money we'll have in the account at the end of those 12 months. So over the course of a year, we went from $1,000 to $1,268.24. That's how compounding interest goes. Okay, you earn interest that gets added to your total, and then you get interest on that interest. That's how compounding works. Now, instead of having to build a whole spreadsheet for this every single time, some real smart person came up with a formula. Now, we talked about exponential functions before we left, before all this stuff happened. And we had y equals a times the quantity, 1 plus b, all raised to the x, where y was the amount at the given time, a was your initial amount, b was your growth rate, or I should say your rate of change. The key was, though, was as a decimal. It's very important. It has to be given as a decimal. Okay, and then x is we said was the cycles. And those cycles could be anything. When we're talking about the M&Ms, one cycle was one pour of those M&Ms out of the cup. When we're talking about a bank account, it could be 1 week, could be 1 day. Okay, now, for compound interest, the formula is just slightly different. Okay, we have different letters here now. Okay, now it looks scarier because there's a fraction, there's multiple things in the decimal, but it's still pretty much the same thing. Okay, A takes the place of Y. A is your amount in the account at the given time. So at time t. P is what's called your principal. Okay, that's your initial deposit. Okay, R is your interest rate. Now the key is here, it has to be as a decimal. Always given as a decimal. So if there is a decimal point, we slide it 2 spots to the left. If there isn't, we still slide a decimal 2 spots to the left. N refers to your compounding periods per year. You know, this will be very clearly stated for you. It will tell you in the story how many times it's compounded per year. And T is your time in the account, and it's always in years. So if they give you it in another unit, you have to change it to years. Okay, so now let's take a look down here. Let's use that formula. There we go. Okay, we want to determine the amount of money in the savings account providing an annual interest rate of 5% compounded monthly. Okay, compounded monthly, that's going to be a big help for us. Okay, if Carol invests $2,000 and left it in the account for 7 years. Okay, so here we go. First thing I'm going to do here, I'm going to insert a little table, if it'll let me. There we go. Okay, and I'm going to say how much each of these things are. So A is what we're trying to find. Getting ahead of myself there. A is what we're trying to find. The principal is how much she started with, which was $2,000. Okay, the interest rate, okay, they said it was 5%, but we know we need to write that as a decimal, so that's 0.05. Okay, N is compounding periods per year. Well, if it's compounded monthly, that's 12 times per year. Okay, and then we have the time that it's in the account in years, and they said it's going to be in there for 7 years. All right, so now we want to take this formula, we want to use it. So what I'm going to do is Control C to copy, and then I'll click down here and Control V to paste. Okay, so there's my formula. Okay, and I'm going to copy and paste it again. Okay, but this time I'm going to change these numbers. Okay, so A is what we're trying to find, so I'm not going to change that. But the principal we said was 2,000. Okay, 1's a constant, that doesn't change. The interest rate, R, we said is 0.05. N is 12. Okay, and it's still 12 up here. And I'm going to multiply that by years, T, which is 7. Okay, I'm going to Control C, Control V again, and I'm going to simplify some of this stuff a little bit. Now I'm going to bring out my calculator down here. There we go. So my calculator, I have 0.0, got to turn it on first, 0.05 divided by 12. All right, that's a crazy repeating decimal. So I'll tell you what I'm going to do. I'm just going to clear this all out, and I'm going to type this in exactly as we see it. All right, so I want 2,000 times, in parentheses, 1 plus 0.05 divided by 12, close those parentheses, raised to the, close too many parentheses there, delete that extra parenthesis, raised to the power of 12 times 7. Okay, now on this calculator, when I push this exponent, it gave me this little box. Okay, yours may not do that. If yours doesn't raise it up into the superscript area, what you want to do is put parentheses after that caret. So raised to the power of, it'll show you, it'll actually have this little caret symbol right here. Okay, put the 12 times 7 in parentheses. Regardless, it's always a good idea to do that. So now I'm going to double check, make sure what I have typed in here is what I want. 2,000 times, in parentheses, 1 plus 0.05 divided by 12, close the parentheses, raised to the power of 12 times 7. Okay, and I'll press equals. So my answer here that I get is 2,836.07. Okay, so that's how much money Carol has in her account. So we'll say Carol will have dollars, $2,836.07 after 7 years. And there we go. All right, let's take a look over here at the second one. So now we've got Eugene. Okay, now Eugene doing something similar to Carol. Hang on here. So I'm going to, if I click on this square right here with the crossed arrows in it, that highlights this whole little table. And I'm going to copy that, Control C, move the calculator out of my way, put my cursor over here underneath Eugene, hit Control V to paste that in. All right, so let's see. Eugene deposited $7,500 into an account. Okay, so that's his initial principal deposit, $7,500. That gives 1.9% APR. APR is annual percentage rate. Okay, so that's his percentage rate. So that's 1.9%. Okay, but we want to change that to a decimal. So that would be 0.19. Keeps going down to the next line, so I'm going to shift this over just a bit. There we go. All right, so now n is how many times it's compounded per year. So it's compounded daily, it says right here, compounded daily. So daily is 365 times a year, so not including leap years is what they say on the next line. How much money will be in the account after 6 years? So we'll change that 7 to 6 if no other transactions are made. So here is Eugene's situation. He's deposited $7,500 into an account. That's his initial deposit. That gives 1.9% APR. That's his percentage rate. Compounded daily. That's 365 times. How much money will be in the account after 6 years, that's our T, if there are no other transactions made? I made one small mistake here. 1.9% should be 0.019. Okay? So make sure you're very careful about that. Now we start out with the exact same formula. A equals P times the quantity 1 plus R over N, all raised to the NT. So I'm going to take that same formula and I'm going to Control C and Control V. So A is still what we're looking for, so that's not going to change. But the principal amount, the $7,500, okay, that is going to change. Excuse me, that is his principal amount, so that's what we're going to put in. Now, the 1 is a constant, that's not going to change. R, the interest rate, okay, that's 0.019, remember 0.019. N is how many times it's compounded per year. And we said if it's compounded daily, that's 365 times per year. Okay, and that N is going to go up here as well in the exponent. And T is the time that it's in that account, which is 6 years. And let's make this fit better. There we go. Okay, now, once again, if I try to simplify this, I'm going to get some pretty wonky decimals. So here's what we do instead. I'm going to come over to the calculator, clear everything out, and type this in exactly as I see it, as close to it as I can. So first 7,500 times, in parentheses, 1 plus 0.019 divided by 365, close those parentheses, raised to the power of. Now again, you see it raised it up to this exponent area. If yours doesn't do that, if yours just shows that caret symbol, make sure you start those parentheses and do 365 times 6 years, close those parentheses. Now, it's really important, guys, before you just press equals and trust whatever answer you get, because you're going to get some really big decimal answers on these. Go back and check and make sure you typed everything correctly. Okay, so 7,500, 7,500, parenthesis 1 plus, parenthesis 1 plus, 0.019 divided by 365, 0.019 divided by 365, close parenthesis, raised to the 365 times 6, raised to the 365 times 6. Okay, we're good. Press equals. We get $8,405.61. So we got to decide on this one. So A equals $8,405.61597. Now it's money, so we got to keep in mind we don't have to round it to 2 decimal places. Well, that means this is what we want to have. Not all of that, just this part. So we have to look at what comes after. We look at this 5. Now 5 or above, remember we round that previous digit up. So this will be 62 cents. So Eugene will have $8,405.62 in his account after 6 years. And there we go. So we have this formula, okay, right here. A equals P times the quantity 1 plus R over N raised to the NT, where A is the amount in the account at the given time T, P is the principal or the initial deposit, R is the interest rate, always has to be written as a decimal, which means slide that decimal point 2 spaces left. Okay, N is how many compounding periods per year, and T is the time in the account, and it has to be in years. Okay, so then we just read the story, find the numbers, and submit. And there we go. All right, guys, there's also an assignment posted to Teams. That assignment's going to be due on Friday. It's only a couple of questions. I'll make sure that there's an answer key for a few of those questions. Additionally, there's going to be a quiz that we'll post on Friday, and it will be due on Friday. We have all day long to get it done, but it will need to be finished on Friday. All right, guys, if you have any questions at all, please feel free to email me. My email account is through Teams. You can get me any way on there that you can find me. Talk to you then.